afternoon to my lecturers and my teammate and my fellow friends. Okay, today we are here to present about our project title, which is passive cascading RL filter band fast filter. Okay, first in this group we have four team members, and first of all I introduce myself. I'm Jamuna Raja, 27 years old. I'm working at Infinium Malacca. Next, I pass to my team members to introduce themselves too.
Hi, I am Hamnet here from FTKE Melaka 2. I am introduce myself first before I explain details about the project. I am 25 years old working at Infineon as a lab technician. I would like to pass my teammate to introduce themselves to.
Okay, hello, assalamualaikum and good evening to all my lecturer and my friend. First of all, thank you for giving me this session. As you know already, my name is Muhammad Fitri bin Abdurrahman. I'm 28 years old. Currently, I'm working at ASE by Lepas Penang as an engineer maintenance and equipment. And then I give to my friends, Shafiq.
Hello, Assalamualaikum, and hello to all my fellow friends and my lecturers. So, my name is Muhammad Shafiq bin Ismail. I'm from Perlis, and this year I'm currently 26 years old. And right now I'm working as a operation technician at TMB Rimako, Pasir Gudang, Johor Bahru.
Okay, we introduce about this project details. I pass to Shafiq to go with the introduction first.
Okay, thank you, Jamuna. Please proceed to the next slide. Okay, so here is what we are going to propose to lecturers and all my members. So our project is very, very good in the future for our new project that we propose to put in the industry. So here is how the introduction and how is the our project works. So the filter is a device allow or frequency component that will go through pass and also will reject the frequency if not meet all the requirement. So they have two basic type of filter, which are passive and active filter. So what is a passive active filter? So passive filter consists of resistor, capacitor, and inductor. But for the active filter, it consists of passive device and also the active device such as operational amplifier. For the passive filter, it doesn't have any active device such as transistor, but the active filter consists of passive device, active device such as operational amplifier that I mentioned before. Sorry for that explanation. Okay, sorry. So we go through to the low pass filter. So the low pass filter is the frequency start at a certain cut off frequency and attenuate frequency above cut off frequency. So as you can see in the figure 1 that I attached in the slide. Okay. Next. Okay. This is the example how the high pass filter works. So for an example, high pass filter is such as a frequency that meet a requirement. For example, right, as you can see in the figure, it start from 0 and then go to the mid and then will stop at 1. So that's mean Let's mean, for example, we have a machine. So the machine we set at the certain frequency, it will cut off or it will not function. So maybe we can relate with the timer or that we use. I want to show you guys high pass filter works. Okay, so this is a formula how you guys to get a proper value, and this is how you calculate the value you want to find the what, find the proper value for the input or output you want. Okay, so next. Okay, Jamuna, ni reverse. Okay, next. Okay, so next we will go through to the tune band pass filter. So actually, tune band pass filter is constructed by cascading two filter, which has a low pass filter and high pass filter. So for you guys to easy to understand, that tune band pass filter have two filter, which are the low and the high filter pass. So this combination, and how the tune band pass filter works is it will find a mid range of frequency to pass through the tune band pass filter, and then it will allow the frequency to go through the tune band pass filter. Okay, next. The important characteristic that consists in the tune band pass filter is the bandwidth. So then the bandwidth, we can define the difference between the high and low cut-off frequency. So that I mentioned to you guys before, the tune band pass filter consists of high and low pass filter. So how to find the difference between the high and low pass filter? We will use the bandwidth that have in the tune band pass filter to find the difference between the high and low pass filter, so that the figure that I attached in the slide before, you can imagine how the tune band pass filter works with the bandwidth. Okay, so next slide. Next slide.
Okay, next slide tu masuk dekat procedures. So that's all for introduction. Okay, for procedures, I would like to pass to Himnat to explain detail about it.
This is the procedures. First of all, the simulation software multisim is used. The simulation circuit is constructed as shown is figure 4. The value of inductor L and resistor R are set as 1H, 1 ohm and 1 ohm respectively. This is the figure. In the simulation setting, AC sweep is selected, and the next one is start the frequency and end frequency are set of 0.0 Hz and 10 Hz respectively. The point of per decade is just 1000 as shown is figure 4 vertical. Scale is a set decibel. Next, start simulation is clicked and the board plot is a screenshot analysis. The center frequency is the bandwidth, and B is calculated based on the simulate board plot and compare with the calculate theoretical and center frequency and bandwidth. The last one, the result are the discussed.
Okay, that's all for procedures. For procedures, later on, I open in multisim and explain detail about the circuit and about the result and simulation. Okay, let's we go for result and discussion. For result and discussion, we would like to give Fitri to explain more about it.
Okay, thank you, Jamuna. So this one for result and discussion. The circuit is given in this segment consists of indicator, inductor, and resistor, which cascading two RL filter together to form a band pass filter as shown in the figure 4. This band pass filter works by utilizing the changing impedance magnitude has a frequency change. Has the equation of indicator which is SL, example WL suggestion, where W stand for unregulated frequency. When the frequency increase, the resistance SL will increase as well because the resistance is direct is proportional. Wait. I cannot see. Can zoom? Zoom please. Okay. To frequency of the power source. As the resistance increase, the voltage across the indicator will increase as well. This makes the RL filter to function as a high pass filter when the voltage is measured across the inductor. Sorry. For the left side of the RL circuit, which consists of L1 and R2, the S is a low pass filter, which means the RL filter has a right side of circuit which consists of R1 and L2 as the high pass filter. Thus, ascending of low pass filter together with high pass filter will get a band pass filter, generating the frequency response as shown in figure 5 and figure 5A. Next please. So this one for figure 5 magnitude plot. Figure 5 show the board plot with the center frequency of 159.59 MHz. The simulation center frequency is similar to the theoretical center frequency as we calculated before, which is 1 Rx equal 1 which means 159.50 MHz. Some minor divisions exist due to limited number of the data point used in simulation. We can compress we can propose by editing the number of the data points is the setting of AC transfer characteristics in multi-sim, but it will increase the data capacity of the simulation. That's all from me. Thank you. This one for me also, Yamuna.
Okay, thank you. Next, for the next slide, I will continue. Okay, this one figure 5A is a phase plot. Okay, figure 6 show the plot with labeling of lower and upper frequency. The lower and upper frequency are chosen based on negative 3.01 dB of the magnitude plot of the both plot. The lower frequency is 48.21 megahertz, while the upper frequency is 5 to 5.38 megahertz. The differences between the lower and upper frequency is bandwidth. Okay, how to calculate a bandwidth is frequency upper minus frequency lower. Okay, so it's shown 5 to 5.38 minus the lower one is 4 to 8.21. So it's equal to 477.17 megahertz. Okay, thus the bandwidth of the system is we calculate 479.13 megahertz based on the simulation output. Okay, the simulated bandwidth value is similar with the theoretical bandwidth, which is 3 radiations equal to 3 over 2 over pi equal to 477.76 megahertz. Okay, for the next slide is the previous I explained about the plot with the bandwidth, right? This is the figure for the plot with bandwidth and the upper and higher frequency. Okay, for the simulation circuit construct in multi-sim, because we use a software which is a multi-sim, we use this circuit and construct in a multi-sim. Okay, the circuit must be ground. The circuit must be grounded, should be ground, else some error will pop up which is invalid further simulation of the construct circuit. If we are not connected with the ground, it will pop up with some error. Okay, the voltmeter is placed parallel to the inductor L2 in order to measure the output voltage across the inductor L2. Okay, L2 is inductor. In the simulation AC analysis, AC transfers characteristics is used as they can vary the frequency from the starting frequency set to the end frequency as by the user. User means the teammates. Okay, keeping the input voltage constant. We keep the voltage constant. Okay, we never change the voltage. Then the output voltage is measured for every subsequent data point. The higher the number of data point, the smoother the simulation output graph will be. Okay, thus the data point should be set to the average value it could like to obtain a higher frequency of data point reading. Okay, that's all for explanation. Okay, we go for the last slide. That is a conclusion of this project. Okay, in this experiment, the objective are achieved. We have studied Okay, sorry for the inconvenience. For this experiment, the objective are achieved. We have studied the characteristics of passive R and L, turn band pass filter. Besides that, we learn to analyze the frequency response, center frequency and bandwidth of turn band pass filter using multisim simulation software. The value of center frequency and the bandwidth of the filter is also validated. The main finding of these experiments is that we learn how to use simulation software to assist us in solving engineering problem and validation. The engineering resulted apart from that, we also understand the fundamental working principle of passive filter, which plays an essential role in elimination unwanted frequency in a electrical system. Okay, the limitation of this experiment is the physical condition of real measuring instrument in the lab are not considered. For example, the temperature of surrounding and resistance of wire will bring some adverse effect of the resultant voltage across the inductor, which might alternate and affect the overall output of the experiment. Okay, that's all for this experiment conclusion, and I could like to thanks everyone who is watching our video, and thank you for all.
Okay, thank you Jamuna for the conclusion. And that's all from us, sir. And I hope you will enjoy and watching my video. Sorry, the video from us. So I hope you will happy with this video, and thank you.
Thank you so much, sir.